So this is the part 2 of the differentiated value, or differentiation equation. So in our previous lecture, in the first part, we were doing up until this much. Now we'll be doing a couple of more examples. So let's say we have another equation. Also remember, consider one thing, try to remember this. We can also represent a function as y equals to fx. Okay, so instead of writing y equals to certain equation, you can also write as, or the equation could also be written as if of x equals to like certain equation, let's say x cubed plus 5x plus 6x squared. Okay, in this way, like we can also write the equation. Let's try to find the differentiation of this equation as well. This is what this should give us. Oh, and we also represent the differentiated values or the differentiated term as f prime of x. This sign is known as f prime. F has a bar at the top. Okay, this is a bar. If this bar sign or apostrophe sign, whatever you say, this is known as a prime sign. Prime, P-R-I-M-E. So this is known as the differentiation of this function. So f prime of x, or the differentiated value of this equation, is we get what the power is going to be brought in the front. So 3 multiplied with x times 3 minus 1 plus there is a constant term. So 5 times we will be getting that 1 at the top of this x. So 1 times x to the power 1 minus 1 plus this constant 6 is going to get multiplied with simply or this term, and we will be like differentiating this x square value. Okay, so differentiating this x square gives us what? 2 times x to the power 2 minus 1. Simply we would get 3 times x square plus 5 into 1, which is 5, and x to the power 1 minus 1 means what? 0. So a 5 into x to the power 0 plus we have 6 to the 12, so 12 times x to the power 2 minus 1 means x to the power 1. So if we rearrange them, since the x to the power 0 is the lowest power, so we can rearrange them in the form of like highest power to the lowest power, so 3x squared plus 12x plus, since x to the power 0 is like means 1, so we can simply write 5. Like this could be also written as 5 times 1, or simply into 5. I mean just 5. So that means we can simply just place a 5 here. So this is the value of f prime of x, or the dy by dx value. Okay, so that's how we also tend to write the equations. Now, doing some other examples. Also, there is one more function which we also need to remember, which is y equals to natural log of x. This ln means natural log. Remember, we used to write logarithm as log, some base, and here was the value x, isn't it? So, or simply like log base 2 of x. And if the base was 10, we can also write it as log base 10 of x, or simply lg x. lg means log base of 10. Simply writing lg means log base of 10. ln means that the log has a base of like exponent, the natural log. The log has a base of exponent. That's why it is written as ln. So this is known as the natural log. Okay, natural logarithm. Now this natural logarithm, when we differentiate this value, we get 1. I mean 1 over whatever is inside. So 1 over whatever is inside into the differentiation of the inner value dx by dt. Okay, so whatever is inside. So if this term was, let's say, okay, let's do it first, then we'll be doing some other examples. So 1 over x, I mean 1 over whatever is inside of this, like that's the bracket. So ln x. So let's just simply write it inside the bracket. It will be easier for you to understand. So let's consider that we are writing everything inside. Like this is known as the inside. Okay, so let's just simply place 2 brackets here and consider that as the inside. So ln of inside, we also say this as ln. Okay, ln or like ln, whatever, but that's the pronunciation, ln. Or you can simply say natural logarithm. So we simply divide the whole thing with whatever is it like inside and multiply it with the differentiated portion of the inside. Okay, whatever is inside, we'll be differentiating it. So that gives us the value of what? This x, if we differentiate it, what do we get? X to the power of 1 here. So 1 times x to the power 1 minus 0. Sorry, 1 minus 1. That gives the value of 1 over x times 1 into x to the power 0, which simply gives us a value of 1 over x into 1 times 1. And finally, that gives us the value of 1 over x. That means what? Simply, the differentiation of ln of x is 1 over x. Now, similarly, if we have, let's say, ln of x squared, then what we do? Like we have done, y equals to ln of x squared. In that portion or over there, we would have also could have done it in two different ways. Okay, let's clear up the board. Remember, we can write log of this 10 some power x. Like if we have let's say if we have 10 square. Okay, how can we write that? We can just simply bring the power to the front. 2 times log 10 base 10, isn't it? That way we can write it. You can also write things as a log lg 5 square. We can simply bring the 2 in front and simply write lg 5, isn't it? That way we can tend to write the values. Similarly, in natural logarithm also, we can bring the power in front. So if we bring the power in front, we get 2 times ln x. So now this is a constant, isn't it? So simply we will be applying our differentiation on this ln x only. Now, what do we get? We just learned that differentiation of ln x is what? Differentiation of ln x is 1 over x. Why? Because whenever we differentiate this ln x, we get 1 over x times, and we need to differentiate the inside term, which is 1 times x to the power 0, which gives us the value of 2 times 1 over x, which means we have a value of 2 over x. Now, this was one of the first methods. Another method is not to bring the power in front. We would simply like apply the differentiation of ln x, what we learned here. Simply differentiate the values. So if we simply try to differentiate it, the inner portion is going to be brought towards the denominator, multiply with the differentiated portion of this inner portion, or which is x squared. That would give us 1 over x squared into the differentiated value of x squared is what? The 2 is going to come in the front. So 2 times x to the power 2 minus 1, which should give us a value of 1 over x squared times 2 into x. Now this x and this x, it cancels out, and the denominated, like in the denominator part, the remaining, we have 1x. Now simply that gives us the value of 2 over x. Simply you can observe that these two values are equal. Okay, so in these two ways we can deal with this differentiation. Now we can also have sinusoidal functions. Let's say fx equals to given 2 cos x plus 3 sin x. Now then, how should we deal with it? Simply remember, if we have arithmetic terms, we are going to individually apply our differentiation. So here we have fx, and if we want to find the f prime of x, or the differentiation of this f, we have to find the differentiation of 2 cos x plus differentiation of 3 sin x. Since our constant term remains, like it doesn't change, we can simply bring that constant in front. Okay, we don't need to deal with that. But the portion which has the x inside it, or x as a part of it, we have to take it as a whole in order to differentiate. Now, if that's the case, If we simply differentiate this inner term, what do we get? We know if we differentiate cos x, we get what? Negative sin x. So negative sin x plus, if we have 3 here, if we differentiate this, we get simply cos x. Okay? If we write this in terms of f prime of x, we get what? Negative 2 sin x, or we can simply write the positive value first, which is 3 cos x minus 2 sin x. Okay, so that's how it works. And remember, this negative sign is not inside this bracket. I mean, this is not with this x. Okay, this is not the case. Rather, this is the separate expression, this is the separate expression, and in together, that's the total final expression. Okay, now we can do a couple of, like, give a couple of examples to be done as a homework. Try to do it by yourself. Remember, there will be many examples which you won't be able to do, but it's completely fine. We'll be covering up this on the next lecture. So the first one is y equals to 3x squared plus 6x plus 5. Then we have y equals to 5x to the power n plus 6x to the power n minus 1. Okay, so these are n, not simply like any numerical values. We have a generalized term n. So this is also the power. We write it clearly. X to the power n plus 6 x to the power n minus 1, 3, y equals to 7x to the power 34 plus 8x to the power 36 plus 9x to the power 108, 4, y equals to e to the power 5x plus 6x squared, 7, fx equals to e to the power 6x squared, 7x. This number is fx equals to e to the power x to the power n. Okay, this is x to the power n. Remember, many of the equation you won't be able to solve, but try it by yourself. And finally, let's say we have, let's give 2 more. Fx equals to t sine x plus t cos x minus t cos 2x minus t sine 4x. Okay. And the 8th number is over here at the above, at the top, which should give us a value. I mean, it should give us a, let's consider the equation f of x equals to 7 sine 3x plus 1 fx plus 2 7 sine 3x plus 1 and then sine 3x square plus 1. Okay, these are the 10 questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm sorry for the the serialization, but I hope this will be a good amount of examples to be followed. So try to do it by yourself. Inshallah, we'll be observing, or we'll be trying to solve them on the next lecture. Okay. Take care. Allah Hafiz. Assalamu alaikum.